Chapter 5, Section 6. This is graphing systems of linear inequalities. Good stuff. All right. The first type of problem that you're going to see is just determining if an ordered pair is a solution to the system. We have a system of inequalities this time, not a system of equations, system of inequalities, because we got our inequality symbols here. And so what we're going to do to check to see if this point is a solution to this system, we'll plug this point into both this inequality and this inequality. And if it's true for both of them, then it is a solution to the system. If it's true for neither, or if it's true for only one, then it's not a solution. It has to be true for both if it's going to be a solution to our system. So just plug it in. The first inequality is 4 times negative 1 minus 3 less than 10. And then the other one is negative 2 times negative 1 plus 2 times 3 greater than negative 8. And we'll just check to see if these are true. So negative 4 minus 3, is that less than 10? We got negative 7 is less than 10. So this one, it works. This one we have 2 plus 6 is greater than negative 8. So we get 8 is greater than negative 8. That is also true. So yes, this negative 1, 3 is a solution. It is a solution because it is true for both of these inequalities when you plug it in. Now the cool part of solving these systems of inequalities by graphing is that you already know how to do this. You simply have to graph this inequality and then graph this inequality, and then you're done. And your solutions will lie in the intersection of these shaded areas. And depending on if you have a dashed line or a solid line, your solutions may be on the line as well. Okay, so let's just start by graphing the first one. Let's see, the first one let's do this one in a red. All right, so let's see, we're gonna have a y-intercept of 2, and we have a slope of negative 2. So this is down 2 over 1, down 2 over 1, down there, okay, up 2, backwards 1, up 2, backwards 1. So we've got, 7 points right there. So I have to look back and see that this is just a simple less than, not less than or equal to. So that means that my line is going to be dashed. So let's get a dashed line in here. And we'll get it as close as we can, and dash, 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 dash. All right. Arrows on both ends. I'm still noticing that folks are not putting arrows on the ends of their lines. Remember, these lines go on forever, and you need to put arrows on them. Okay, so we can check to see which side we're going to shade. By plugging in, we could plug in 0, 0. So if I take this and I plug in 0, 0 up here, we'll try to do this off to this side here. This is going to be 0 is less than negative 2 times 0 plus 2. So 0 less than, that's going to be 0 plus 2. So 0 is less than 2. That is true, which means that 0, 0 should be part of our shaded region. So we'll shade that in. And I wish I would have chosen a larger dot for my shading. All right, so that's the shading for the red. Okay. Let's do blue for the next one. So we've got blue. So I've got a y-intercept of 0, negative 1, and then a slope of negative 1. So that's going to be down 1, over 1, up 1, backwards 1, We're going to look like this. Okay, so this is going to be a solid line when we draw it because we've got greater than or equal to. So we will draw a nice line just like that. Okay, arrows, arrows. All right, well, we can see our intersection point for our lines is here. But what we're interested in, because these are inequalities, is we're going to be looking for where are they, where's the shading intersect, because that's where our solutions are going to lie. So, let's see, we'll plug in 0, 0, check to see if that works. So 0. So this is going to be just -1. So 0, is that greater than or equal to -1? That's true. So that means that we're going to shade where 0, 0 is. So that's going to be or to the side where 0, 0 is. That's up in here. So there's all of our blue. Now the solutions are going to lie where our blue shading and our red shading overlap. And we also have these boundaries here. So this blue line is going to serve as a boundary. The dashed red line will serve as a boundary. And then all the stuff that's inside here where we have our red and blue shading, that's where all of our solutions lie. And then because this line is a solid line, all the solutions, the red shading is covering where that line is. So the points on that line are also going to be solutions to this system. The points on this line, even though the blue shading overlaps, this is a dash line, so we're not including that dash line in the red solution. So the points that are on this line are not going to be part of our solutions. So our solutions are just inside here and then along this line until it reaches here, and then it is beyond that, the stuff down here, that there's no overlap. And so it's just this line to here and everything in there. And that's it. We're done. We've graphed our solutions and shown the solutions to this system by graphing.